Variable camshaft timing is a new development from Ford which is due to be applied to the company's mid-range engines. VCT, as it's known, is a device that can vary the timing of one camshaft relative to another while an engine is running and according to engine operating conditions. The result is that valve overlap is altered and the engine's performance characteristics changed. If fitted to the inlet camshaft, as on the 1.7-litre Zetec S unit, VCT will help improve the engine's power and torque. However, if fitted to the exhaust camshaft, as on this American Ford engine, VCT will help control emissions by reducing the levels of harmful oxides of nitrogen. The VCT unit locates inside the camshaft sprocket and fits to the end of the camshaft. It's an oil-driven actuator, in effect a hydraulic cylinder. The principal components are a housing with helical gears inside its central hub. This bolts to the camshaft sprocket. There's an oil sleeve that fits over the central hub of the housing. There's a spring that locates inside the sleeve. Then there's a hydraulic piston with inner and outer helical gears. These outer gears engage with the helical gears in the housing so that piston movement causes a twisting motion. Finally, there's a center hub, also with outer helical gears. This engages with the inner gears of the hydraulic piston. This center hub also bolts firmly to the end of the camshaft. Therefore, any movement of the hydraulic piston twists the hub and the camshaft. An outer cover seals the unit to the backplate of the housing, and the camshaft sprocket also bolts to that backplate. When fitted to the inlet camshaft of the 1.7-litre Zetec S engine, the effect of any movement of the hydraulic piston can be clearly seen. As the piston moves from a forward position to the rear, so the camshaft rotates. This effectively advances camshaft timing and causes an earlier opening and closing of the inlet valves. Similarly, as the piston returns to its forward position, the camshaft rotates to its original position, in effect retarding camshaft timing to create a later opening of the inlet valves. The piston movement is caused by varying the pressure of oil fed to two chambers either side of the hydraulic piston. By feeding oil pressurized by the engine's oil pump to the forward chamber, and at the same time allowing oil in the rear chamber to drain back to the oil pan, the piston is moved to its rear position. By reversing this process, the piston returns to its forward position. There is a third state. If oil either side of the piston is isolated from the effect of the engine's oil pump and also prevented from draining back into the oil pan, the piston will be suspended in whatever position it happens to be. Whenever the engine is not running, the piston rests in its forward position. The feed of pressurized oil is controlled by a solenoid valve that responds to instruction from the engine's electronic management system. Inside the solenoid is a control plunger. Its shape forms three separate chambers between it and the cylinder wall: an upper chamber, middle chamber, and lower chamber. The plunger can also be moved between three different positions: upper, lower, and middle. When the engine is running, pressurized oil is fed to the central chamber. As the plunger is moved to the lower position by the solenoid, that pressurized oil is released into the lower chamber. From there, the oil travels to a flange that surrounds not only the camshaft, but also the VCT bush. The oil passes into the center of the camshaft, along the camshaft, through a hollow bolt that secures the VCT unit to the camshaft, and finally into the forward chamber. However, If the control plunger in the solenoid is moved to its upper position, pressurized oil is released into the upper chamber. From there, the oil again travels to the flange surrounding the bush and camshaft, but by a different route. It passes through longitudinal drillings in the bush to reach the rear chamber behind the hydraulic piston. Whenever the engine is running, pressurized or unpressurized oil can be found either side of the hydraulic piston and in the feed channels. Whether the oil is pressurized or not depends on the position of the solenoid control plunger. As the plunger is moved to its upper position, this not only releases pressurized oil to the upper chamber, it also opens the lower chamber, allowing oil to flow back to the oil pan. This variation in pressure either side of the hydraulic piston is what moves the piston, in this case, to its forward position. If the plunger in the solenoid is moved to its lower position, oil in the upper chamber is allowed to drain back, while pressurized oil is released to the lower chamber. The hydraulic piston moves to its rear position. If the plunger in the solenoid is moved to its central position, the central chamber, full of pressurized oil, is isolated from the upper and lower chambers. Similarly, oil in those upper and lower chambers can't escape back to the oil pan. This has the effect of freezing or suspending the hydraulic piston wherever it may be, and so holding camshaft timing in that position. The engine's electronic management system receives information from two sensors in particular that help determine camshaft timing: the crank position sensor and the camshaft position sensor. Unlike other Zetec engines that don't have variable camshaft timing, this camshaft position sensor not only reads a single tooth on the inlet camshaft to help time the sequential fuel injection on startup, but also 4 more equally spaced teeth that enable the sensor to measure the exact camshaft position at all times. The engine management system is controlled by the latest EEC5 electronic module. This not only receives a constant stream of information from the crank position sensor and the camshaft position sensor, as we've seen, but also the mass airflow sensor, located in the air intake, the air intake temperature sensor, the engine coolant temperature sensor, and the throttle position sensor. Information from all these sensors is used to help control the VCT solenoid, and so set inlet camshaft timing as appropriate to engine operating conditions. Variable camshaft timing, leading-edge technology from Ford that further enhances the company's highly successful mid-range engine.